In this example, we're factoring x to the fourth minus 16y to the fourth. And believe it or not, this is the difference of two perfect squares. So let's write the formula down. Write it down every time you use it until you have it memorized. So, okay, a squared minus b squared is equal to quantity a plus b times quantity a minus b. Remember, you first want to look for a GCF to factor out. There isn't one other than 1, so we don't worry about that. And then we identify what's acting like a. Well, first off, what's acting like a squared? Oh, yeah, x to the fourth is going to be our a squared. That's my claim. So what's a in this case? Well, I claim that a would be x squared, since if you take x squared and square it, you'll get x to the fourth. Think about it. X squared squared means x squared times itself. And we know a law of exponents that says when you multiply like bases, you keep that base and add those exponents. 2 plus 2 is 4. Another way to get it is another law of exponents. When you see an exponent on the inside and an exponent on the outside, you keep the base and multiply the exponents, and 2 times 2 is also 4, so you get x to the fourth. So either law of exponents you use, you can realize that, oh, a is x squared in this case. And then what's acting like b? Well, b squared is 16y to the fourth. So what is b? b is essentially the square root, or a square root, of 16y to the fourth. So here's my claim. I claim that the square root of 16y to the fourth, you can take square roots individually because the square root breaks up over multiplication. The square root of 16 is 4, and the square root of y to the fourth is going to be y squared. And if you don't believe it, just take 4y squared times itself, and you'll get 16y to the fourth back again. So, by the way, any even power of a base, say x, or it really doesn't matter what the base is, you could say m. M to any even power, like 4, 2, 4, 6, 8, is going to be a perfect square. And to get its square root, you can just keep the base and divide the exponent by 2. So if it's like m to the 8th, keep the base m and divide the exponent by 2 to get the new exponent is what I'm trying to say. And it's m to the fourth. Think about it. M to the fourth squared, m to the fourth times itself is m to the 8th. That trick will work for finding the square root of any base like x or m or y brought to an even power. Any even power is a perfect square. So anyway, all this stuff in purple, after you get good at this, is what goes on in your head. And then once you have your a and your b, you just plug and chug into the formula. Take a plus b and then a minus b. So in this case, we get a plus b would be x squared plus 4y squared. And a minus b would be x squared minus 4y squared. And the thing is, you might be breathing a sigh of relief thinking we're done, but we're not done. Because if you look at that second factor, the first factor is good. We can't factor that anymore. But this second factor is also a difference of two perfect squares. Now, we don't have a formula for the sum of two perfect squares. So this guy is done. Don't cross it out, but it is done. This guy is not done. So we once again have to use the formula for the difference of two perfect squares to factor that thing. In this case, a is going to be, what do we square to get the guy in front? Oh, we square x. So a squared is x squared. That means a is x. And b squared is 4y squared. So what do we square to get 4y squared? So that's b squared. That's for this particular factor anyway, that's a squared. So what do we square to get 4y squared? Well, that's going to just be 2y. And then we're going to apply the formula all over again, a plus b, a minus b, on this second factor here. Don't forget to rewrite down that first factor, x squared plus 4y squared. That's not going anywhere. And then the second factor, x squared minus 4y squared, it factors further to be x plus 2y times as a quantity times the quantity x minus 2y. And now it's factored all the way, and you are expected to factor polynomials as far as they can go.